Hello, hi everyone. Welcome to the Student the Brand. So this is your Siva sir. Hello, hi everyone. Welcome to the Student the Brand. So this is your Siva sir. Today we are going to discuss about scalars and vectors. Scalars and vectors. So what exactly is scalars and what exactly vectors? We'll discuss about it. Okay. So first of all, we should know the quantity. Generally, if you go to shop, the people will ask you, so when you go to shop and immediately if you ask shopkeeper, I want rice, I want so dal, I want chocolates. So likewise, immediately the shopkeeper will ask you how many you want, for how much you want, right? So if it is rice, how many kgs you want, for how much you want, like that he will ask. So the answer for how much or how many, or simply we can say, so it is a quantity, amount or vastness, that is called quantity. Okay. So physical quantity, the quantity which can be measurable, the quantity which can be measurable is called physical quantity. The quantity which can be measurable is called physical quantity. So here there are number of physical quantities like our weight, mass, speed, velocity, acceleration. These all are physical quantity, means the quantity which can be measurable. Okay, so here we'll talk about scalars and vectors. So now we are going to discuss, we are discussing about scalars and vectors. So what is scalar? Scalar is nothing but the quantity which has only magnitude, it doesn't have any direction. Suppose you take 1 kg or 2 meter per second speed. So the physical quantity which has only magnitude. Okay. So if you want to describe the physical quantity, if it is required only magnitude to explain that, then that quantity is called scalar physical quantity. Coming to vector physical quantity, or simply we can say vector quantity, the quantity which has both magnitude and direction. The quantity which has both magnitude and direction. Suppose we can take the body is moving from one point to another point, initial to final point, direct path. Okay. So the shortest path from initial point to final point. Here quantity is there, at the same time direction is there. Okay. So displacement is a vector physical quantity, and velocity is a vector physical quantity, and acceleration is a vector quantity. Understood? So these are all about scalars and vectors. Scalars and vectors. Okay. Scalars and vectors. Scalars and vectors. Okay. So the quantity which has both only magnitude, that is called scalar quantity. The physical quantity which has both magnitude and direction, that is called vector physical quantity. Okay. So now we are talking about vector physical quantities. Vector physical quantity. So first one is equal vector, equal vector, equal vector, equal vectors. Second one is negative vectors, negative vectors. Third one is null vector, null vector, or zero vector, zero vector. And coming to the fourth one, unit vector, unit vector, unit vector. And coming to the fifth one, equal vector, negative vector, null vector, zero vector, unit vector, orthogonal unit vector, orthogonal unit vector, unit vectors. So sixth one, co-initial vectors, and co-initial vectors. Seventh one is coplanar vector, coplanar vector, coplanar vector. Coming to eighth one, so collinear vector, collinear vector. Next, ninth one, localized vector, localized vector, localized vector. So tenth one, non-localized vector, non-localized vector. Okay, so here you can observe these are the types of vectors, types of vectors. So equal vectors, negative vectors, null vector. Okay, null vector, orthogonal unit vector, orthogonal unit vectors, co-initial vector, coplanar vector, collinear vector, localized vector, non-localized vector. Still, so displacement vector, okay, position vector, like that are there. So we will discuss about these vectors. So equal vectors, the vectors whose magnitudes are equal and at the same time acting in the same direction. Those are called equal vectors. Magnitudes are same, at the same time acting in the same direction. Coming to the negative vector. Negative vector, equal magnitude but opposite direction. Null vector, the vector whose magnitude is 0. The vector whose magnitude is 0, that is called null vector. Okay, so I hope it is very clear. Okay, understood or not? So check once. Right? So next one, unit vectors. The vector whose initial power is, so if I am taking a cap equal to a bar by mod a bar. Okay, so if I am taking a bar equal to, so xi cap plus yj cap plus zk cap. So if I am taking, so like 2i cap, 3j cap, 4k cap, like this also we can take. Okay, so now you can see here a bar equal to 2i cap plus 3j cap plus 2k cap. So if you are taking magnitude root over 2 square plus 3 square plus 2 square, then you'll get 4 plus 9 plus 4, that is nothing but 17. Okay, so that is a magnitude. So you'll get magnitude like that. Okay, a mod a bar, mod a bar. Understood or not? So 8 plus 9, 17. Okay. So now orthogonal unit vectors, orthogonal unit vectors. The vectors are acting along the, so like this we can find out the unit vectors. Like this we can find out the unit vectors. Coming to orthogonal unit vectors, the vectors are acting along x-axis, y-axis and z-axis. Along x-axis I cap, along y-axis j cap. I cap is a unit vector along x-axis, j cap is a unit vector along y-axis. So k cap is the unit vector along z axis. I cap is the unit vector along x axis. J cap is the unit vector along y axis. And k cap is the unit vector along z axis. Okay. Co-initial vectors. Co-initial vectors. So here, so all initial points are same. Initial points of the vectors are same. So I am taking this the A bar vector and B bar vector. So their initial point is same. So here you can observe this is the A bar vector, B bar vector. Their initial point is same. That is called co-initial vectors. Coming to coplanar vectors. Coplanar vectors. So they are acting in the same plane, like xy plane. So like this. Okay. So next one, collinear vectors. The vectors are acting in the same line. Okay, either in forward direction or backward direction. So vectors are acting in the same line. Coming to localized vector. Localized vector means the vector whose initial point is fixed. Initial point is fixed. So here, non-localized vector, the vector whose initial point is not fixed. Localized vector, the vector whose initial point is fixed. Non-localized vector, the vector whose initial point is not fixed. That is called non-localized vector. Understood? Scalars and vectors. Equal vectors. Equal vectors. So vectors are having same magnitude and acting the same direction. Negative vectors. Vectors have same magnitude but acting opposite to each other. Null vector, the vector whose magnitude is 0, so that is null vector or 0 vector. Orthogonal unit vectors. Okay, the vectors I cap, j cap, k cap. I cap along x axis, j cap along y axis, k cap along z axis. These are the orthogonal unit vectors. Orthogonal unit vectors. And coming to the co-initial vectors. So all the vectors whose initial point is fixed. So initial point is same. So the vectors whose initial point is same, those are called co-initial vectors. Coming to coplanar vectors. Vectors are acting in the same plane. Next one, collinear vectors. Vectors are acting in the same line. Okay. Whether forward or backward, same line. So same direction or opposite direction. So acting in the same line. And localized vector. Localized vector. Localized vector is nothing but the vector whose initial point is fixed. That is called localized vector. Coming to non-localized vector, the vector whose initial point is not fixed. The vector whose initial point is not fixed. So these are the localized vector, non-localized vector. I hope it is very clear. Understood? So these are the types of vectors. Types of vectors. Next. So next we will discuss about addition of vectors. So next position vector, displacement vector. Okay, so different types are there. Co-terminal vectors. Okay, so likewise. So now we are discussing about addition of vectors. Addition of vectors. So there are three types of addition of vectors. One is triangular vector. Second one is parallelogram vector. Third one is polygon vectors. Okay. So first one is addition of vectors. Addition of vectors. Addition of vectors. First one is, so what is that one? Triangle of vector. Triangle of vector. triangle of vectors. Second one is parallelogram of vectors. Parallelogram of vectors. Parallelogram of vectors. And coming to third one, polygon law of vectors. Fourth one is, third one is polygon law of vectors. Polygon law of vectors. Okay. So, polygon law of vectors. Polygon law of vectors. Polygon law of vectors. So, coming to triangle of vectors. Triangle of vectors. Understood? So, triangle of vectors are nothing but triangle of vectors. Okay, two sides are acting along the, so two vectors are acting along the two sides of the triangle. So A bar and B bar along same direction. The resultant will be opposite of these two vectors. So C bar. So you can observe C bar is acting opposite to of, so remaining two vectors. So A bar and B bar. Understood or not? C bar is a resultant vector which is acting opposite to of remaining two vectors. So C bar equal to A bar plus B bar. Okay. C bar equal to A bar plus B bar. A bar plus B bar. So that is addition of vectors in the form of triangle of vectors. Triangle of vectors. Coming to parallelogram vectors. Parallelogram vectors. Okay. So now we'll discuss about parallelogram vectors. Parallelogram. Parallelogram vectors. Parallelogram vectors. Parallelogram law of vectors. Parallelogram law of vectors. Okay. Two vectors are acting along the two sides of the parallelogram. Two vectors are acting along the two sides of the parallelogram. Okay. So here I am considering here this the vector A bar and this the B bar. The angle between A bar and B bar is theta. The angle between A bar and B bar is theta. Understood? So now, so along A bar I am drawing this parallel to A bar and parallel to B bar I am drawing here like this. So extending the x-axis and drawing parallel to y-axis, x and y, angle is theta. Okay, so the resultant will be diagonal of these two vectors. The resultant will be diagonal of these two vectors. Understood? Resultant will be okay. So now I am taking here The resultant will be diagonal of these two vectors, that is the resultant R bar. Okay. So now, so if you take this triangle, if you take this triangle, okay, like this is X, Y and B. So this is the theta. Okay. Now we can take cos. So cos theta equal to adjacent side by hypotenuse, that is x equal to b cos theta, and sin theta equal to y by b, that is equal to y equal to b sin theta. Understood? X equal to b cos theta, y equal to b sin theta. Now I want the resultant. So here you can write now. You can write y equal to b sin theta, x equal to b cos theta. Okay, y equal to b sin theta, x equal to b cos theta. So the resultant equal to a plus x. So here x value also we have to add. X value you have to add. Understood or not? A plus x whole square. So r square. R square equal to a plus x whole square plus y square. Okay. So a plus x. So r square equal to a plus b cos theta whole square plus b sin theta whole square. Okay. So r square equal to a plus b cos theta whole square, then b sin theta whole square. So r square equal to, we know a plus b whole square formula. A plus b whole square formula, a square plus b square plus 2ab. A plus b whole square formula. So same, a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. So we know sin square theta plus cos square theta equal to 1. Okay. Sin square theta plus cos square theta equal to 1. Sin square theta plus cos square theta equal to 1. Understood? So like that we can take, like that. Is it clear? So now, so here you can observe. So here in these two terms, we can take it r square equal to a square plus b square cos square theta plus sin square theta equal to 2ab cos theta. Okay, 2ab cos theta. Now you can take r square equal to a square plus b square plus 2ab. Sorry. Now r equal to root over a square plus b square plus 2ab cos theta. Understood or not? So like this we have to take. Like this we have to take. Is it clear? So one check. So parallelogram of vectors. So two vectors are taking along the two sides of the parallelogram. The resultant will be diagonal of these two vectors. Okay. Then we can take, if you extend x-axis and y-axis, so along x-axis and along y-axis, then from right angle triangle we can take x equal to b cos theta, y equal to b sin theta. The resultant equal to a plus x whole square plus y square equal to So r square plus a plus b cos theta whole square plus b sin theta whole square. Then you'll get the values. Then the resultant equal to root over a square plus b square plus 2ab cos theta. Okay. So this is about parallelogram vectors. Parallelogram vectors. Next one, polygon law vectors. Polygon law vectors. Polygon law vectors. Okay. Polygon law vectors. Polygon law vectors. Polygon law vectors. Polygon law vectors. Okay, so vectors are taking along the sides of the parallelogram along the same direction. The resultant will be opposite of the vectors. Okay, so the resultant will be opposite of all the vectors. The resultant will be opposite of all the vectors. So here you can observe. So here, okay, the resultant will be along opposite of all the vectors. So you like this, understood? So here you can take this A bar, B bar, C bar, D bar, E bar and F bar. F bar is the resultant. So F bar equal to, so A bar plus B bar plus C bar plus D bar plus E bar. Okay. So this is the resultant of the vector. Resultant. Understood or not? Next one we will discuss about product of vectors. Product of vectors. Okay. So let's start. Product of vectors. 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 There are two types of product of vectors. One is dot product or scalar product or scalar product. Dot product or scalar product. Second one is cross product or vector product. Cross product or vector product. Vector product. So what is a dot product? Dot product is nothing but, so the dot product of two vectors is equal to product of their magnitude and a cosine angle between them. Okay, so that is a dot product. Coming to cross product of two vectors is equal to product of their magnitude and a sine angle between them and n cap unit vector. Okay, so this is about scalars and vectors. If you like the content, if you like the channel, please do like, share and subscribe to Student the Brand. So this is your Siva sir. Thank you so much for joining and attending listening class. So this is your Siva sir. So we'll come to the class with a different topic. Thank you.